There's two more topics I want to talk about. One is very practical. It's selecting refrigerants. So if somebody said, hey, I need an important design choice. I'm a design engineer working for a refrigeration company. What is going to be some really important things to consider? And then on this list, what's the least important? Everything's important, but the least important, you know, it's not the top. Is it the thermodynamic performance, especially how it gives us a high COP, safety in case it sprays out and some workers get exposed to it, environmental impact, so it gets out and affects the sky and everything else in the environment, or the initial cost? In your estimation, today in 2018, what do you think is the least important of these four things? This is not a trick question. Yeah, but your opinion. What's your opinion? Yeah, in 2018, today, you know, right now. In the 50s, it was different. In the 1950s, it was different. What's the least important today? In the 50s, environmental impact was the least important. I agree. But today, what's the least important? Initial cost is the least important. This has blossomed and cannot be ignored by engineers. Shouldn't be ignored by engineers if it has a serious environmental impact. Well, for many years, it was performance, safety, and now it's environmental impact. I'm going to talk about the early 1920s when they brought about refrigeration. And some things were not necessarily very safe. They were toxic. Do you want to be exposed to toxic materials? No. They were flammable. Do you want to be around when there's an accident with a flammable refrigerant? No. So basically, the 30s brought in, because of some loss of life and some accidents, some synthetic refrigerants, man-made refrigerants, which were excellent for performance, for safety, but not so excellent for environmental impact. This goes back to 1929. You can look around 1920s, and you'll see this in Chicago especially, New York especially. They were bringing in mechanical refrigerators for indoor environment in apartments or high-rise buildings and stuff. Well, those refrigerants were not necessarily the safest. In this one, it's methylchlorine gas. So it leaks into an apartment. Somebody sleeping in the apartment, they're dead. And they had a number of these. And so that really motivated engineers and scientists to develop safer refrigerants. And then they did. They developed those refrigerants like the R11, R22, R12s, etc. So a lot of them were developed, especially in the 30s. They were very, very, very popular. And often they attach some chlorine with some fluoro and some carbons, so either chlorofluorocarbons or hydrochlorofluorocarbons. And chloral is here, and you have the carbon, hydrogen, and fluorines, etc. You could take a look at them. Well, some of those they always escape out into the environment. Okay, when they escape, where does the lighter refrigerants go? High into the atmosphere. And then after a lot of studying, the scientists figured out that, oh, the depletion or holes in the ozone layer way high is due to refrigerants. They get up, they interact with the sun and the light rays, and then they eat up the O3, that's the ozone that's up there. And the ozone that's up there is beautiful and great for absorbing the UV light. And so we're not bathed with more harmful UV light down here on our skin and stuff. Okay, so the international agreement, after it was figured out what was happening way up there in the sky, was to ban the production of certain chlorine-containing man-made refrigerants responsible for the ozone layer depletion. So the Montreal Protocol in the United States signed on and had a big impact on engineers working in refrigeration. Then they also figured out not just ozone depleting, but global warming potential. That's another metric to gauge the environmental impact of refrigerants. And they would take a list of refrigerants and they would say, how good are you for ozone potential? If your number is low, that's good. If the number is high, that's bad, easy to discern. Likewise, for the global warming potential, they put it relative to carbon dioxide, okay? And they normalize it, and so if you're in here, you're good for low global warming potential. If you're out here, it's bad. And then they see, okay, some refrigerants, they get good here, bad there, but you want to be down here with the refrigerants that are good for both. They're not going to deplete the ozone and not going to be contributing to the global warming. Well, that brings us to like CO2 and other refrigerants, and the world continues to change. Okay, refrigerants that were out there 20, 30 years ago are not the same 10 years ago, and not the same in another 10 years. But CO2 is a refrigerant. They even have the refrigerant number 744. Is got some benefits, but it also has some drawbacks. It needs high pressures, and whenever you have a system with high pressures, you have a sealing of that system, and you can have leaks out of that system. High pressures lead to more leaks, which are bad, but because it's high pressure, it's good for density of the fluid, good for thermal properties like heat transfer characteristics. It's inexpensive and very widely available. You can get it. And you can get it all over the world. CO2 is not very hard to get, and it's very stable. You can, heat it, cool it, put it through machinery. And this is a big one right here. There's a low potential for legislative phase out. Some government's not going to pass a law and say you can't now use that refrigerant, which has happened in the past. So some manufacturers have said, okay, we're going to invest a lot of resources to make this refrigerant, our equipment really work well with this refrigerant. And then, oops, that refrigerant's now banned. Not good for business. Trane actually kind of was a loner, as I understand it, and they picked some refrigerants that other companies said, nah, that's not the winner. It's like calling a race. Which horse is going to win the race? But then lately, kind of their picks a couple years ago turned out to be good picks, and other manufacturers having to adapt. But this was out of an article in 2016. You could, if you're interested. I don't have time to get into it, and actually I'm not an expert in all the nuances of the new refrigerants out there. But the world is changing, and the world's not going to accept a more toxic refrigerant, and it's going to trade off between thermal performance and environmental impact and cost. All right, refrigerants should have low ozone depletion potential and low global warming potential, C. Why have refrigerant 12 and refrigerant 22 been phased out? Well, they're too expensive. They're harmful to the atmosphere. They are toxic. They're flammable. Manufacturers in Montreal and Protocol agreed to stop making them in 1987. And I have given this on final exams, and there have been a number of students, oh yeah, that's it. Montreal Protocol 87, that's got to be it. Well, yeah, I'm giving them a choice that looks tempting, but it's completely bogus. It's where the people got together and had an international agreement and everybody signed on. All right. In Montreal. Carbon dioxide continues to be considered as a refrigerant for air conditioning applications because the ozone depleting potential is 0, global warming potential of 1, or both A and B. Both A and B. Yeah, really good. The problem with it, you have to have high pressures, and it's going to leak. It's just going to leak. Which has not been used as a refrigerant? Methyl chloride, diethylene glycol, difluoroethane, carbon dioxide, propane. We'll take a show of hand, or one hand at a time. Yes, sir. Propane. We got a vote for propane. Somebody else. We're going to do some votes here. Yes, sir. B, diethylene glycol. I had this on a final exam too. Somebody else. Come on, it's a fun game. You just got to raise your hand and give me your answer. I only have 2 out of 60 students who are ambitious. Yes, sir. Propane. All right. One of those is the winner. Don't vote for anything but B or E. Got it? We are in a horse race, 3-3. B is pulling out ahead. Diethylene glycol is a colorless, soluble liquid used antifreeze. Yes, propane is used as a refrigerant. It may be flammable, but it is used as a refrigerant. What percent of refrigerants eventually leak into the atmosphere? This is well beyond the textbook, but just using your insights is the way the world works. You know, I buy a window air conditioner. 20, 30 years later, where is the refrigerant that was in the window air conditioner that I bought 10 years ago and then I threw out into the dump 5 years after I bought it? Where is the refrigerant that was in it? So you're able to recover 90% and reuse and prevent from escaping to the atmosphere? You said 10%? Okay, but you want to say 99%. Because essentially everything that you produce, the vast majority of it is eventually just going to leak out. I mean, I hate to say it, but that's what it is. Anybody worked with service technicians in HVAC systems, and then they get a call out, and the first thing they check, oh yeah, you're low on refrigerant. Where did the refrigerant go if you're low? Last month you came out, it was perfect. It leaked. Into the atmosphere it goes. So this is actually, if you're interested in things like that, this is a Greenpeace. It's actually a very good report I found, and it talks about, hey, these gases, they're eventually going to be, you can seal them up, use them for 10 years or so, but unless you're able to capture them and destroy them, they're going to get out into the atmosphere. So it's better not to produce them in the first place. That's what they do when they outlaw certain production of refrigerants. Well, that ends that part of the discussion.